Awesome. Yeah, so I'm going to take it from here. I've got a lot to say. So this is a new talk. So really often I recycle my talks in different ways, but this is brand new, fresh off the press. I thought that the conference was tomorrow because as it turns out, it is tomorrow already in Australia. So I was looking at the dates on the website. I've got until Tuesday. So I put together these slides over the past few hours and the weekend. So really fresh stuff. So really looking at the opportunity to check point on trends around touching data teams, touching the data engineer, touching organizations that are data driven. So I'm going to get started in just a second. But before then, just like a quick intro. So I think I got a fairly good intro already. So I'm going to go quickly through this, but I've been, so my entire career, so it's probably 20 years or so by now, been really focused on working with data and building data tools in different contexts. So been doing that for quite a while. And then since 2014, I've had a chance to work in the open, so working on open source. So 2014, when I joined Airbnb, I started working right away on Apache Airflow, or what became Apache Airflow. And we got some really good traction internally and externally very quickly. It turns out a lot of people needed something like Airflow at the time. And soon after, so it was the following summer, so less than a year after, I started working on Apache Superset. As I mentioned earlier, so Apache Superset is in the data exploration visualization. It's very much a business intelligence solution for modern data teams to explore, put together a dashboard, explore their data, put together dashboards, share them. There's also a SQL IDE in there. So I encourage people to check out Apache Superset if you haven't, or if you haven't in a while, because the project and the product itself moving extremely fast now. So we've accelerated just the pace at which the product is growing and getting awesome. So encourage people to take a look if you haven't in a while. And then more recently, so a few years back, to a little bit more than 2 years ago, I started a company called Preset. So we're at preset.io, and we are very much like offering Superset as a service with a freemium offering. So that means you can try Superset for free, up to 5 people, and you can get started and check it out and see if it works for you. So that was the commercial bit here, and I'm going to get right into the keynote. I wanted to thank the organizers too. So it takes a lot to organize a conference. I know it because I've been involved in the organization of some of these. So thanks to the sponsors and to the organizers. It takes a lot to make this kind of event possible. So what am I going to be talking about today? So I don't know how many people in this audience have came across the 2 blog posts that are referenced in here, but about like 4 or 5 years ago, I wrote The Rise of the Data Engineer, and the idea was really to go and formalize the role, this emerging role at the time, and talk about like what is a data engineer, and what do they do, what do they not do, who do they work with, this sort of thing. So and then soon after, I wrote about some of the challenges around the role and some of the things that made it really hard to be a data engineer at that time. So some of the challenges and opportunities, that came with those challenges that existed at the time. So more recently, I thought like it'd be a good time to checkpoint and to talk about how this has evolved. So my plan was to go and rehash some of this stuff and to go like point by point and be like, okay, look at what has changed and how it has changed. But the talk that I prepared today derived a little bit from that. And I think I'm going to be much more interested today in talking about just emerging trends and not be anchored on these posts. But it is very much a checkpoint. So I'm going to be looking at trends around the data engineer. So trends in data teams, trends in data organizations. I'm going to try to talk about how these trends affect the data engineer role today. So that should be fairly interesting if you're a practitioner, if you're a data professional, if you care about data in any shape or form, you'll be able to look at, to listen and see how much you can relate. Wanted to say too that the goal here is to go pretty wide and shallow. So I'm not looking to go into a lot of depth in any of these trends. And I'm also working on a blog post that's going to be probably highlighting a lot of supporting evidence for the trends that I'm claiming. Keep in mind that this is very subjective in some way to my experience, right? So I'm sitting here in the middle of Silicon Valley, and my experience is very related to my vantage point. Actually, out of my window behind me here, I can see the Oracle buildings, just to provide context as to like where I sit. So I'm in the middle of Silicon Valley. I'm also in the middle of the open source communities and the modern data stack type of efforts. So, so that, you know, provides some context as to what I'm observing may or may not relate to you in different ways because of my vantage. Without further ado, so I'm going to start jumping into these trends and talking about them. So the idea here is I'm going to cover about like 14 or 15 trends and just talk about what these trends are and what they mean to data engineers. So one thing that has changed a lot over the past 4 or 5 years since I wrote these blog posts is that data infrastructure existed as a service at the time, but we've seen the rise of the pay-as-you-go model with things that scale to infinity in the form of hosted SaaS, right? So that means that the accessibility of the tooling and the variety of the tooling and the cost effectiveness of the tooling as all of this has been very, very transformative. From the data warehouse offerings themselves, right, with things like Snowflake and BigQuery and Athena, and all of the data warehouse offerings around like just getting tools that work where you can get started in minutes. You pay as you go. If you have little data, it costs almost nothing to run these services. And you can get started in minutes and get like a world-class service. So in the rise of the data engineer, I was trying to create a distinction between the role of the data engineer with in regards to the data infrastructure engineer. And I think what we're seeing now is that the data infrastructure engineer is likely to work at Google Cloud, or is likely to work in a place like Confluent, Databricks, Preset, right? And these people become people who provide a service to the entire world. So that means that companies like Airbnb, or at least like companies that will become the Airbnb and the Lyft and the Facebook of the future, are likely to have less of a data infrastructure team in that role to go towards vendors and cloud service provider, which is a great thing because it's just, we get much more economies of scale in that way, right? It's more efficient for a small group of people to run Superset for the whole world at Preset than having an engineer or two run such service in every company in the world. So we've seen also like just more variety in the tooling, and tooling that is more catered to different personas and different workflows to support different workflows. So, and all these services are increasingly kind of pay as you go, try for free, which has been great for data teams and for everyone really. So accessibility it goes directly with this idea, right? So that means that maybe smaller companies it was hard for smaller companies to have a data team or to be good with data because of the tooling was either prohibitively expensive or just not accessible. And now it's just easier for any team to be a data team, which is a really important topic to me. That's actually our mission at Preset, is to enable every team to become a data team. And, you know, certainly in the information age, it's important that everyone can have access to great data tools and great data infrastructure. The next trend I'm going to talk about is the rise of data integration services. So data integration is actually a term that I've used over the past 20 years, right? So it's not a new thing in any way, but the shape and form it has taken has completely changed over that period of time. So we used to have like more box software that would be really hard to integrate. And now what we've seen over the past like decade or a little bit longer than a decade is a move towards SaaS in general, right? So nowadays, the average startup runs more than 100 SaaS services. And this is super great because anyone can have access to very useful tools, right? Whether it's for payroll or HR or your recruiting and applicant tracking systems, your CRM tool. So everyone has access to really great tools. That created an issue in a sense that the data would be very siloed, right? So if you use Salesforce, you use HubSpot, you use Lever or whatever tool you pick to manage your business, you would create all of these silos that would be kind of isolated with the data stuck in these different places. So about 4 or 5 years ago, the way that you would deal with this is you would start to essentially like write a bunch of script, or either you'd give up, if you're a small enough company, or it's hard for you to or if there's not enough ROI for you to do this, but you would start writing script to go and scrape essentially or bring data using API calls in tools like Salesforce. That was really prohibitive and brittle and kind of awful work for data engineers, right? So if you think about a data engineer, you're a data engineer 5 years ago, and your goal is to integrate with HubSpot and synchronize your customer list and your deal list and your contact list. This is not super fun work. It's very brittle. You have to update your API. So that used to be very painful and brittle and error prone. And just not that interesting of work. And nowadays we see the emergence of tools like Segment, Fivetran. On the open source front, there's Meltano and Airbyte. I think there's Stitch powering or Singer, Stitch, other tools that are just make it easier for people to integrate their data. So that's a great advancement. It's something definitely to embrace. The fact that it's easier now to collect data and bring it to your data warehouse, or even to integrate point to point in many cases. We've also seen the reverse ETL space become more common, and the tooling starting to emerge. So I think we're fairly early in that area, but that's high touch Grouper. I'm sure there's other solutions. Those are just the ones that I know. So it's not like vendor preference or anything like that. It's more like I know these tools, and I know people are using them. So the idea with reverse ETL is like bringing data from the warehouse and into your marketing type tools or CRM or anything really, right? The idea is to take data from the data warehouse and bring it back to SaaS services. So a lot of advancements there. And I mean, what does that mean for the data engineer? Is like you don't have to deal with that directly. You can focus on the transform layer. You can focus on infrastructure and on frameworks, as opposed to writing these like point-to-point integrations or these like integration to scrape data to bring it to the data warehouse. Next topic. So ELT over ETL. So I think people talk about this like it's kind of a new trend. I wanted to mention it here. I don't think it's new. To me, ELT has been strong, and maybe I need to define what that is. I'm pretty sure most people in the crowd will have an idea what this is about, but maybe an easy way to explain this is whether the transformations are done inside the data warehouse using typically SQL. So that would be in the case of ELT, right? You extract your data from your source systems, or you use your Fivetran, Meltano, Airbyte to bring your data from your source systems raw to your data warehouse, and then you do your transformation inside the data warehouse using typically SQL. ETL is more in the traditional ways. We add specialized tools that would enable you to do this, things like SQL Server integration services, Informatica, things like Ab Initio and IBM Data Integrator. Forgot, but so there's all these tools that were doing computation in a specific tool. So it would extract your data, transform it in that ETL tool, and then send it back to the database. As it turns out, databases are really good at processing tons of distributed data in the absolute best way. So it does make a lot of sense to reuse the resources that you use for querying or for your analytical workload on your database, to reuse these tools and this infrastructure to process your transformations as well. So I think we're seeing more and more that the data warehouse is the place where transformations are getting done. Of course, there are things like ML workloads and things that require computation that databases might not be able to do as easily. So I'd call it more advanced custom transformations. My belief in that area is that we're going to see more ways to write, UDF, so user-defined functions, are ways to bring the compute that you want to bring to your Snowflake, your BigQuery, your Athena, right? So to bring your computation to the distributed engine that is the data warehouse. Moving on, next one is, I call it mountains of templated SQL and YAML. And this one, first I'm going to talk about the trend and talk a little bit about what that means. But clearly, I think, just to start with a little bit of history, when I started writing Airflow in 2014, I knew that a lot of what it's going to be used for was going to be to schedule templated SQL. So I baked Jinja, which is a templating engine, deep into the Airflow engine so that we could do that very well. So at the time, it was clearly, a large percentage of ETL, call it 50 to 90%, was authored as SQL, right? So I would say the majority of transformation expressed as SQL. For a moment there, we thought that data frames-based APIs and things like Spark or different ways to things like Apache Beam would become a more mainstream and more expressive way to write data pipelines. And I think what we've seen recently with just the way that Airflow is being used and the rise of tooling like dbt, that people are doubling down on using templated SQL and templated YAML as a way to express their transformation. There's a lot of really good reasons for that. SQL is declarative. It's lingua franca of data. It's easy to learn. It is widely known, widely adopted. It is very much a standard language, and it seems like people relate to its expressiveness. What does that say about, is that good, is that bad? For me, it's hard to get excited about a bunch of templated SQL. It's also hard for me to think about an alternative that I want to use, right? So for our data warehouse, for our own use cases at Preset, we selected templated SQL and YAML as well, just because it's common, it's easy, works well. It's a great way to talk to the database. So it's an obvious choice. And it has implication in the sense that if you want to build a lot of reusable components and frameworks, you end up with these like macros, so Jinja macros, and these constructs that are dealing with assembling strings together to try to write SQL dynamically. And sometimes that's not a very expressive and great way to build things. So a lot of implications there. I'm planning on writing a blog post on this specific topic of like what does that mean for our industry, and really like maybe what would be preferable and what are the challenges that comes with another decade, presumably, of a lot of transformation written as mountains of templated SQL and YAML. The next topic that I have is the rise of the analytics engineer, which I think is really interesting and very related to the accessibility of the previous slide. So what we've seen recently, and it's hard to qualify that movement, outside of my vantage point, but is more so analysts, so people who are sitting and that are more vertically aligned. And by that, I mean they are sitting part of their product teams often, right? So they sit with people with whom they share goals, as opposed to sitting with people with whom they share skills. And that means that the analysts, first affiliation is to the product team. And analysts I've learned to, essentially, they've learned SQL, they've learned Git, and they've learned YAML, and now they can write data pipelines, which is a great thing, right? Every time we see more data literacy and more people being able to build more things, it's a great thing. I think this has a lot of implications for the data engineers. I'm going to try to to explain that. To me, it is a core function of data engineering too, to author a transformation, whether it be as SQL or not as SQL. And the skill requires are knowing SQL, being good at data modeling, and of course, caring about all the things that data engineers care about, which are things like SLAs and performance and data quality and all of these things. So what is there to say else on this topic? There's probably the something around what does that mean for a data engineer, right? So now that you have hordes of analysts or a handful of analysts maybe in your team that are also checking in code and writing SQL, I think there's a role. Presumably, maybe the data engineer is closer to infrastructure, closer to data modeling best practices, closer to writing sustainable code on the long run, maybe has more experience doing so. So I think there's a role of education and support of like, how do we support this new role as data engineer? How do we support analysts in writing great SQL, reviewing code, following the naming conventions, and then maybe writing data quality assertions and all of this. So I think there's a little bit of a DevOps type role. The DevOps equivalent, or call it data ops, role becomes more prominent for the data engineer. And there's also a role of education and code review and defining excellence and best practices, and things like SQL linting maybe might be a topic, right? How do we make sure that the SQL looks and consistent? So lots of implications there. Is it eroding away from the data engineer? I don't think so. I think it's still core to the role of the data engineer to write data transformation. It's just like now there's a new friend on the block, right, helping out and also like trying to get work done. So there's a question of how we team up and work together. Data literacy and specialization on the rise. So a lot to say here. We are, as I mentioned earlier, in the information age, and data has certainly been a focus, and it will stay a focus for the decades ahead. So that means that more and more people are becoming rapidly more sophisticated with data. And that's because those skills are very valuable to be a modern information worker, right? So this trend is not about to stop. It's taking different shapes and form. And one of those is analysts learning to speak SQL and learning Git, right? Like that's like, if you want to be a great analyst, you're probably going to have to be great at creating data structures and managing them and maintaining them. And you have to be great at data modeling. So that's very true and will stay true. What are some other examples of that? So I think I'm going to make that point in a future trend that's very related to this one, which is the next one. Maybe I'll pivot to the next slide, and I might be kind of in between these two slides and go a little bit back and forth. But maybe one more point on this one is that increasingly being sophisticated with data and being able to partake in the analytics process, which I will define here, it is a really important skill to all information workers. So everyone that works in an office or in front of a computer, the more skills you have with data, the more it will correlate with your ability to do your job, which is a great thing for us as data professionals. So democratization of the analytics process. Let me talk about this. So I think it's widely, the sentence that you've heard and overheard is democratization of access to data, right? So everyone, that's a very well accepted trend that more and more people should have more and more access to data. And that's very much a consumption related statement of like knowing how to consume data, interpret data, make decisions that are based on data. Now, the trend I'm talking about here goes wider than that. So I'm talking here about the overall analytics process, which I define as the process by which data gets instrumented, curated, wrangled, transformed, augmented, and ultimately consumed and weaved into processes, right? Like how the data flows from its creation all the way to the right place that's powering the right person to make the right decision or to power the right process, whatever it is. So I have some examples of this at a very high level. And these statements might be more or less true depending on your vantage point, but these are things that I've observed. PMs are more involved in instrumentation and measuring product impact. Engineers are more involved in instrumenting things up front, right, in terms of like collecting the right data up front. More people in different roles are defining metrics, dimensions, business rules. There's more data flowing into daily processes and operational tooling. And then there's feature stores that are emerging. I won't get too deep into that, but I think ML-minded people are understanding the importance of data engineering to achieve their data science or ML-related goals. I think I'm going to accelerate the pace a little bit too here. I don't know exactly how I'm doing on time, but I think I have probably another 5 minutes before we have a question session. So think about your questions, everyone. Here, I'm really passionate about this one. I think it's a really interesting trend. Every product out there is more and more becoming a data product, or is integrating data visualization components, interactive data viz component, has, in some cases, real-time data flowing into it. So I think over the next decade, every product out there is likely to become increasingly a data product, which has some deep implication for the role of the data engineer. So that means that instead of being more passive consumption of data at rest, we're going to see a lot more active data that's flowing, and that has to be production grade, right? As highly visible product becomes data product, the need for reliability of the pipeline, there's more tension around that. So I won't get too deep into that as I'm accelerating. Another trend, big one, I could probably talk about that one for an hour or two, but here the point being the emergence of data ops and data, here I call it data obs, which sounds awful, but I meant to write data observability, pushed by a more tension and more desire around more guarantees around data quality, right? So I think like data reliability, data quality, data like trust in data is becoming more important as data becomes more centric to what everyone does across organizations. And I think we're only going to see more data ops, data observability. You can probably do a parallel with the DevOps movement and say that in some ways we might be maybe 5 years, 10 years behind on the data world on software engineering. I don't know if that's a true and fair statement, but in terms of like, if you look at the DevOps movement and how mature it is versus like the data ops and data observability movement, I think we're behind on the data side. And we're starting to see emergence of all sorts of tooling to make that better. This one I'm going to go fairly quickly on, is this idea of the erosion of the BI semantic layer. So for those familiar with the semantic layer, for those not familiar with the semantic layer, business intelligence tools, things like Tableau, Looker, historically business object MicroStrategy, had this thing called the semantic, that people would refer to as the semantic layer, which is a lot of metadata around how data can be joined and used, information about metrics and labels and description. So this layer seems to be somewhat eroding away from the BI tool and moving in parts to the transform layer and other places. Well, I would say in other places, I would say the data catalog and the data discovery challenge, which is the problem space of being able to find your data assets and understand how they are related to each other. is still like a big problem space, and probably too big for any given BI tool to manage. So there we're seeing the data discovery, data graph route moving to data catalogs type application, and things like Amundsen and Data Hub that are open source project trying to solve and attack this problem. And as teams use multiple BI tools and use things like dbt and Airflow, we have to share that metadata with other tooling. And historically, the BI layer has not been open enough to provide the guarantees of sharing and integrating with other tools. So I think there's going to be a lot of work around metadata in general and metadata management. And that's going to become a primary or an increasingly in focus item for data engineers, right? To manage, to treat the metadata like it is a really worthy and a really important thing. There's a clear trend there. All right, a few more trends before we pivot into the question section. Decentralization of ownership. So that is maybe a larger organization challenge here, where what we're seeing is that we used to have central data teams that would be managing the data for the rest of the organization, and we're seeing every team becoming a data team. So that has very deep and complex implication around who manages and owns things, and how metrics dimensions are defined, and who owns pipelines that treat data that are useful to multiple teams. So over time, I think we're going from a more centralized model, which is obsolete and just as proven not to work, at least in larger organization, and into more like a hub and spoke model, which is a decentralized kind of picture in the middle there. There's this initiative or effort, I'm not sure how to call it, but this thing called data mesh that does a good job at identifying some of the challenges around this and tries to propose some solutions. And it's unclear, exactly whether those solutions are like how to put them into practice. But it's a clear trend that we need to decentralize the ownership of data, as large organizations need to collaborate on data structures. Here, I'm going to go talk a little bit about Computation Framework, and this is a little bit more looking at the future. So here, there's an emergence of frameworks that are probably, let me try to describe them in a way that's like somewhat comprehensive. So you can think of maybe a framework, something like dbt or Airflow, as a place where you can define these data transformations. What we're realizing is really often these things are too open-ended, right? If you look at if the framework is you write whatever SQL you want, there's no guarantee, there's not enough constraint, or there's not enough guarantees for this to be usable. So constraints around who owns this and how things define and how are transformations expressed. So what we're starting to see is call it like layer 2 solutions on top of SQL that or on top of SQL or other pipeline frameworks, right? So the general idea being offering these higher level constructs and interfaces that are more opinionated as to what kind of transformation should be done and how they should be expressed. Often those are defined as SQL and YAML, where you say, here's my data set, here's the transformation that I want to apply, here's who the owner is, here's how it relates to other transformation or metrics and dimensions that exist in my data warehouse. And then these computation frameworks offer more guarantees in terms of how things get computed and what results are created. There's some good blog posts out of Airbnb around something called Minerva, talking about their metrics layer. We've seen similar things emerge at large companies like places like Facebook, Netflix, Lyft, and other places. We've We've seen special purpose computation frameworks, notably around the feature engineering problem, closer to ML, the metrics layer, as I mentioned. There's also other special purpose frameworks to compute things like engagement metrics and growth accounting metrics. And I'm hoping this is a place where we're going to see more reference implementation and more projects emerge over the next few years, right? So people sharing these constructs that are more opinionated as to how to do certain types of transformations. People might think like this is really ungrounded. I don't know what you're talking about. I gave some other talks in the past around this topic. Part of what I wanted to do when I created Airflow originally, I had the hope that people would use Airflow as a DSL to create these more special purpose computation frameworks. And we've seen very little of that happen. So I still think that's something we're going to see more and more of in the future. And that gets me to my conclusions slide. So talk about a few caveats I mentioned at the beginning. So first is like, things are moving really fast, and depending where you sit in the universe, you might observe completely different things. And I wanted to say too that my experience is subjective in the sense that I sit in a very not unique place, but my vantage point is from the middle of Silicon Valley. I wanted to give the pointer that there will be an upcoming blog post on this with more structure, hopefully, and more supporting evidence. So here I'm making big claims without showing data. So I'm hoping the blog post is going to have a lot of references and a lot of pointers to other articles and to data and evidence in general. And then I wanted to say, like, data engineering is still very much in its infancy, right? If you compare to software engineering, we are behind in some ways, and I would say our maturity, where we are in the maturities curve, is just earlier, and that creates a lot of opportunities for all of us data engineers. So the future has yet to be built, and I wanted to tell people, to try to inspire people to say, like, go build that future. It's not built yet. Like, we have not figured out data ops and data observability, and there's tons of tooling that we'll need that does not exist today. And I think that's super exciting to think about. With that, I'm going to conclude with just a pointer to urge you to go and try Apache Superset if you haven't tried it in a while or ever. And the best way to do that is to get started on preset, where you can run freemium. You can get started in the next 2 minutes if you want to, and get started on preset. So